Okay, alright, so let's put this back together. So let's try these out.
Bryce,
What
what was the ratio of these, or proportion you set
the
up?
big idea of similar triangles, 15 over x
sides
are
I'm
proportional.
not going to agree with that.
Okay, that's the big
Not,
idea.
see how these are separated like
Look at number
almost
5, we
completely
got
across the
5 and
triangle?
6.
That's not the pair you want to use.
They're on,
They
they have
X
to have
and
the
9.
same side of the
How
angle
can I set up a
bisector.
proportion to solve that?
Actually, this is probably a good way. Let me actually erase that one. Do that one again. I never thought about this before. Surely never thought about it. If you extend the angle bisector,
Now, why don't you use 6 over 9?
pair them up because they're on the same side.
So 12 and x are paired together. So 3.
Okay, good. The easy way to identify which of these actually correlate
X over
is notice that this is the
Okay.
single arc.
All right.
Then the
Now, which one?
box.
Is it x over 12 or
What's
12 over
between
x?
them?
6, right?
You go to the other triangle,
I
what's
agree.
between the box and the arc?
9, so those are your corresponding values. Okay.
Now, some of you guys might have set this up differently.
All right.
What if you had 6 over 5 equals 9 over x? Is that still working?
Yeah.
What? The 6 corresponds to the 9, doesn't it?
Yes.
And the 5 corresponds to the x, doesn't it? No. What if I did x over 5 equals 9 over guys, the last problem
9
here
over
is
6.
a little
Does that
tricky.
work?
Yes.
Okay, guys, here's what I want to point out to you. All 3 of these work. In fact, there's a lot of different options for you.
This one actually is a really tricky problem.
We start working on these. You guys come in with homework questions tomorrow.
Why
You
is
and I
this
might
different
set up
than
the
the others?
initial problem differently.
Yeah,
we don't have the other half.
What is
We
true
don't
on
have
all
this
3 of
part right
these?
here. Are the cross products. 6 times x.
5
Sure.
times 9.
Down here,
6 times x.
15,
9 times 5.
18 minus
6
6
times x. 9
equals
times 5.
10.
okay? So when you're setting your proportion correctly, no matter how you set it up, your cross products should be the
Make sure we
same.
take the time and
Okay, so
explain
it's a really
where
important thing to
18
remember
minus
about
x
this.
comes from.
Your cross products are the same. So let's go ahead and solve our problem.
Part of it.
So if we have
Exactly.
6x
I'm going to
equals
go ahead and kind of go
5,
almost
how would
from
you solve for x?
a piece of wood.
Okay, so
Board.
x is 45, 6.
Okay.
And that'd be
And if I tell you
reduced
this board is 18 feet,
by 3,
and this portion is 5 feet,
18
what's
over
left over?
2.
How'd you get that? You did 18 minus 5, right? So if I have an unknown,
we are going to save number 6.
Yes. What's the other side?
Only because I have several of these we're going to show today.
Same
We will
concept.
come back to number 6 after that note.
So once you want to start making that connection, that just because you're not always given something, doesn't mean that you can't write an expression to represent that missing piece.
Don't give me that.
That happens a
Unless
lot in
you're going
math.
to have to give me a decimal.
That's one of those skills, those little tricks of the trade that you need to remember.
Really, Sean? Congratulations. But I don't know.
Okay.
It's awesome. Very proud of Alright, guys, number 8 is. Alright, guys, here we go. Let's go ahead and cross multiply.
Similar triangles.
So we get 15x.
This is one of those applications
equals
that
10.
is extremely
Now, this is
crucial.
where you gotta be careful, right? You gotta make sure you
Given our
understand how to
location
write
here
mathematics.
at high school, I tried doing here this
Yeah, so you gotta make sure you write it as
Nature
10
of
times
this
the
is what I
quantity.
used to do at my old
18
school.
minus x. And it's actually kind of a cool activity, and it's unfortunate we just don't have anything to do it with here. Middle school you guys have done it? Okay. Well, this is actually kind of simple. If you take a man
Maybe.
who's 2 meters tall,
First time.
okay, so we're 2 meters tall,
I'm gonna more copies last. I think it's
and he casts a shadow that is 6 meters long, it actually sets up a triangle. Okay. And based on a little bit of earth science here, this angle here is what we call
Alright, can you guys solve it from there?
No. Sun angle.
That's the angle that the sun is making with the ground at that point.
Alright, guys, here we go.
Ready
to go ahead.
So if you ever want to know what is the
Whoa, slow
angle
down.
that the sun's making with the ground, it's easy
So
to
15x
Just take your head, measure your shadow, and that's the angle.
Okay.
Okay. So if I take a tree, or a tall building in this case,
You will add 10x,
uh-huh,
15x.
with an unknown height,
Okay.
that casts
X is 180
a
over
36
25. Can that be
meter
reduced?
It's 5.
So what does that give me?
long shadow.
Yeah.
Again, the sun angle for these two, because especially if they're done at the same time, will be the same angle.
So we have our two similar triangles.
All right, any questions on
They're
that?
angle. So therefore the
Four
ratio
examples of
must
this.
be
No, same.
Go back to the one.
so 2
All right,
over
so go back to number
x
eight.
is equal to okay, our number 6. Okay guys, here we go. So look at number 6. How would you set up this problem?
So x over
So
x
height of
plus
the building
3.
is
Ivan. 4 over 6. Can that be reduced?
yeah,
To what?
what's the oh okay.
2/3. Okay, now what? Yeah. Oh.
Breaking it
Cross
down even
multiply. Yeah, because right here you can easily break that down. It's 1 to 6 actually. I mean, like that. There's a lot of different ways to look at this. Ivan, that works great. Okay. Okay. You're not always going to get that nice simple deal. So if you can do it like that, I still want to see the work that you've done it that way. Voila. Okay. Show me where you got the 1 to 3, and then I'll run with that. Okay. I'm all right with that. One of the ways I look at it is I look at shadow to shadow. So to go from 6 to 36, you have to
Now,
multiply
the
by
last part of our
6,
notes,
so
I
what do you
have
do
3
to the height?
slides I want to go over with you
Multiply by
guys.
6, I'm at 12. Okay.
I want
I
you
like
guys
what you did
put on
there.
your
The
thinking
height
caps.
is 1/3 of the shadow.
This is not going to be a
A third
direct
of
instruction
36.
sort of deal. I mean, I'll be up
Well,
here kind of walking
multiple ways to
guide
do
you
proportional
through
problems. Here's the real
Make sure
issue.
they're all
I'm
set
going
up
to walk you
correctly.
guys
I don't
and
think
guide
so.
you to forming your own concept. All right, there is a
All right.
major concept I want you to learn
This
about
is what
ratio
leads you in order to do
versus the ratio of these areas.
And it's
So,
this
let's
concept
start
of
off
angle
with
squares.
bisectors.
So squares are very simple. So there's 2 properties I need you to take out of today's lesson with
So,
angle bisectors.
And an angle bisector
I want you to complete this
similar
slide.
triangles. This only works if the triangles are already similar.
Find the perimeters of
If it
square
is,
A
then the
and
lengths
square
of the
B.
angle bisectors are proportional to the
And then I want you to find the ratio of the sides of A to B.
Guys, how many guys ever built a model?
And then I want you to find the ratio of the perimeters on a plane or a car or something like that. Okay? Everything in there is built to scale, correct? Here we go.
It's usually like a 1
What
to
is the
20.
perimeter of square A?
What that means is
Okay,
everything,
12,
even
12.
the width of the steering wheel,
3. What is the
is
perimeter of
built
square
to
B?
scale.
24.
So it completely makes
Okay,
sense that if you had two
All
triangles
right,
that are similar,
Come on, Sebastian.
what does that tell you
What
about
is
the length of
ratio
their
of my
angle
sides of
bisector?
A to B?
Uh,
A over B is equal to
No,
1.
not half.
Your quote.
But it is built to scale. So whatever the ratio is of
Here,
here
3 to 6,
from
from
B,
B,
C
C
down
to
to
E,
F
1/2. Good.
is
All right,
same
so,
scale as from G
Caitlin,
to C.
what is the ratio of my perimeters?
Okay, so it's just
The perimeter
basic common
of
sense.
A
If you have two things that are the same
B
ratios,
is
then
what?
everything within them will be the same ratio.
So 12 over 24, which reduces down to.
B to A would be the same as from E
What
to
did
D.
you notice?
And the
about
ratio of
of
BA
perimeters
ED
versus the ratio
would
of
be
the
the same
sides?
as BC.
It's the same. Make sure you understand that. The
So we
ratio
kind of
of
say,
perimeters
if you want to really look at it, you can say FH to GC
Now things are going to get weird.
is equal to, say, EF to
That's really simple. Understand that the ratio
or,
of
I mean, there's a lot of
is
these
the
things.
same as the ratio of the sides.
EF, AC,
Now, so guys, let me ask you this.
or VA,
Let's say I had. Oh, where's my
or
Next one.
TE
The same thing with this side. What are you doing?
to VA.
Area. How do you find area of a square?
Base times side.
Alright, this is the one that's really kind of important here. If you have an angle bisector in a single triangle, within a single triangle,
Very
it
good.
creates
Shannon, what'd you get for the area of B?
similar triangles.
Alright, so
that's what that concept's saying. If I have an angle bisector in a single triangle, it
Okay,
creates
very
two
good. So, Earlier we said that the ratio
Similar
of sides of
triangles.
AD
Basically, it makes the sides proportional.
1/2. Now, if you take the ratio of your areas,
So what that
area of
means
A,
is the ratio of BD
area of B
to CD
is 9
is equal to
36,
AB
is
over AC.
how does 1/4 compare to 1/2?
Connor, why
You are
aren't
correct,
you
but
doing
you're wrong. This is the wrong connection. Okay? Right now, it's not really obvious what the connection is. That's because the issue was here before. But I'm going to show you guys a little more. This time, follow me on this. I'm going
It's
to
gotta-
take
The
6.
similarity, you gotta move past that, right? It's they're not equal, the ratios are equal.
Repeat that now with 9.
Alright, so we have 4 of these I
So
want to do
now
together.
with that, that's 9. Only 1, which is now 1.
Now to set this up, here's what I normally do. I call
Guys,
it
now
inch
follow me on this,
theorem.
please. Quiet.
Or like the tweezer theorem. And here's why. Think about it
Ratio
like
at
this.
the beginning was 1/3 or 1/2, correct?
Well,
What's the ratio now?
Squeezing it together.
How do you go
That's
from
your one
1/2
ratio
to
right there.
1/4 and from
So you can
1/3
think
to
of that
1/9?
as
Times it by 3.
Sebastian?
24 to 9.
Square. Guys, this is
Equal
the
to
big
what?
idea. The big idea with ratios
No, and
are
then just
basically
solve from
with
there.
the perimeters.
Now, guys, I'm not sure about
areas,
you, but I'm not really a
similar
big fan of
figures.
multiplying 18 by 9.
Big idea.
And then having to divide by 24.
Well,
The ratios of the perimeters of similar figures is R. Whatever the ratio is, it's the same thing for the
The
perimeters.
24 over 9 can
But
be
what about for
and
the...
was it reduced by?
8.
So 8/3 equals... But the ratio of the areas
Now what?
is the square of the ratio. So, I mean, it kind of makes sense. No. If I tell you that
Cross
I
cancel
have
works when you're multiplying.
tripled my
Then
length,
what
what
have
have
I
I
done by
times
area?
18 over x? Yes, you can do that.
No, if I triple my length, what have I done to the area?
So you can't do
I
it
multiply
cross
by
reduction.
If I take my sides and multiply by 4, what have I done to my area?
Don't worry about it.
Multiply by 16.
Okay, so we're divided by 8.
You squared the
So
ratio.
I get x is equal
So guys, it's really important. Okay, now how many guys are in any kind of like digital electronics? I really think that kind of stuff is pretty cool. Okay?
2.
So let's say you start designing something. You want to double. You want to make it twice as big. What's the problem? If you have the settings, think about this for a minute.
Yep.
You want to make something twice as big,
Cross
you think,
multiply
oh,
by
let's double all the sides. Well, what does that actually do?
That's it. That's all this whole
It makes
lesson
it
about.
4 times as
Setting
big.
up the proportion, which is the hard
If you
part.
double the sides,
Cross multiply
it
and
makes
divide.
it
and
4
you're done.
times as big.
Nothing to worry about.
So you can't use
Okay, what about
2
number 20?
as your multiplying factor.
What if you only have
Oh, I'm sorry, no, next
If
problem.
you have
Number
you have a triangle, you multiply everything by 2, doesn't matter. The area of the triangle has now been quadrupled.
Wait, so if you only go for one side, how could 20 over 16?
No, so now we're just being silly. Okay?
Guys, that's the big ideas I want you to take out of today's notes.
2, or okay, now what? And x is
That's reduces.
So the same triangle, if it's in the same triangle, you just
if it's in the same triangle, you just take the ratios of the ends. Corbin?
Why wouldn't it be 20 or 20 to x and 16 to 4? Because 20 is the longer side, x is the longer side.
Because what it does, Corbin, if we go back to here, it basically separates the opposite side, so it separates out which would be your BC, okay, into length proportional to the 2 other sides of the triangle. So BD gets paired with AB, DC gets paired with AC. Okay? That's how it works. It's not so much we're talking about smaller with larger. Okay? This is kind of how we're looking at it from this point. It's this to here, and this to here. Okay, here we go. Next one up here. I want you guys to try this one on your own.